Well, hello and welcome to your first lesson of online learning here. We're starting out with lesson 6.6, yard work in segments. So we are going to work through this lesson together. I'll ask you to pause the video at various points in time for you to try things on your own before we continue on. So let's go ahead and start right in. As you can see, Malik's family has purchased a new house with an unfinished yard, and they drew the following map of the backyard. So they've plotted it on a coordinate plane here. Malik and his family are using the map to set up gardens and a patio for the yard. They plan to lay out the yard with stakes and strings so that they know where to plant grass, flowers, or vegetables. They want to begin with a vegetable garden that will be parallel to the fence shown at the top of the map above. So when we're thinking about things that are parallel, we of course just mean that their slopes are the same. Okay, so they set the first stake at -9,6 and the stake at the end of the garden at 3,10. They want to mark the middle of the garden with another stake. Where should the stake that is the midpoint of the segment between the two end stakes be located? Using a diagram, describe your strategy for finding this point. So here is where I would like for you to pause this video and go ahead and try for yourself to figure out how you can find the midpoint using a diagram. All right, so hopefully you've tried something. Generally, what we need to do when we're trying to find a diagram or to make a diagram for the midpoint is we need to look at the slopes, right? This line is diagonal, so we don't know exactly how long it is. We can see that we go over 3 and up 1, but that doesn't tell us how long this side is right here. So it's hard to tell where the midpoint is. However, if we keep using those slope little right triangles, we can see that it actually takes 4 of them in order to go the entire length of that line there, the parallel line that they've plotted. Which, if it takes 4 of them, we know that the midpoint of 4 is just 2, so we can actually just look at 1, 2, and that means that our midpoint is right here. All right, those little triangles right there as well, those are our diagrams. You also could have thought about a larger triangle, okay? It'll be the same slope, but this right here might be a larger triangle and another larger triangle here. Then you can see that it is 1/2 more clearly than 2/4, for example. All right, so there we go. Malik figured out the midpoint by saying just that. It makes sense to me that the midpoint is going to be halfway over and halfway up, so I drew a right triangle, cut the horizontal side in half, and the vertical side in half, like this. So he both cut the horizontal side in half and the vertical side in half, and what he ended up doing was he created those two right triangles, those two larger right triangles, by cutting those sides in half. Malik continued, that put me right at -3,8. The only thing that seems funny about that to me is that I know the base of the big triangle was 12 and the height of the triangle was 4. So I thought the midpoint might be 6,2. So in number 2, go ahead and explain to Malik why the logic that made him think the midpoint was 6,2 is almost right, and how to extend his thinking to use the coordinates of the endpoints to get the midpoint of -3,6. So go ahead and pause here and make an effort to do that. Alrighty, now that you've had a chance to do that, we're going to go ahead and talk about that together. So, explaining why the logic was almost right, he's assuming with this 6,2, he's just taking the height and dividing it by 2, and the length and dividing it by 2. However, that kind of doesn't account for the fact that we don't start at the origin. We're not starting at 0, 0. This point here is our starting point. So we're actually 6 away from the starting point here and 2 away from the starting point here, right? But we're in reference to this point here rather than the origin. Malik's sister, Sapana, looked at his drawing and said, "Hey, I drew the same picture, but I noticed the two smaller triangles that were formed were congruent. Since I didn't know for sure what the midpoint was, I called it x comma y, just an ordered pair. Then I used that point to write an expression for the length of the sides of the small triangles. For instance, I figured that the base of the lower triangle was x minus a negative 9. Just looking at the distance between those two. So what you need to do is label all the other legs of the two smaller right triangles using Sapana's strategy. So if this here is x minus a negative 9, this might be y minus negative 2. So go ahead and take the next few minutes on your own to go ahead and try this leg and this leg. So what Sapana is looking at is this leg right here being x minus a negative 9. Another example here is this y value here. We'll do x minus, and here we're not going to do 2, even though the length of this space is 2. We're actually going to look at this y value here, plug it in over here, just like that x value we took there, we plugged in right there. So it'll be at y minus 6. So go ahead and give yourself a try for these sides right here. Remember, you should start with the more positive x and y values as well. So these two will be more positive than these two. Go ahead and pause the video here and try that on your own. Hopefully you were successful in that, and hopefully as we start with the more positive values, you got 10 minus y, our two y values there subtracted from one another, and for this lower horizontal line, you got 3 minus x. That's how those should be labeled right there. So if you weren't quite there, go ahead and make some changes and get there. Let's go ahead and look on to the next page here. So Sapana continued, once I labeled the right triangles, I wrote the equations by making the bases equal and the heights equal. So our question is, does Sapana's strategy work? And you need to show why or why not. So go ahead and pause the video for a moment and do that. Okay, does Sapana's strategy work? Show why or why not. So we are going to go ahead and do just what she says, writing the equations and making the bases equal and the heights equal. So we'll take our bases, x minus negative 9, and 3 minus x, and set them equal. We'll also take our heights, y minus 6, and 10 minus y, and set them equal. And we're going to just go ahead and solve for x and y. I like positive numbers. So for 1, we've got that as a positive, but I'm going to add these x's over here. I like my variables to be positive. So I will have 2x plus 9 equals 3. Now I'm going to do the reverse of PEMDAS, subtract 9 from each side, and I get 2x is equal to negative 6. Divide both sides by 2, and I get x is equal to negative 3. All right, we've got our x value solved for. Now I'm going to do that same thing with the y. I'm going to add y to both sides. I get 2y minus 6 equals 10. Add 6 to both sides, if you can see it right there. And I will get 2y equals 16. Now the final process is dividing both sides by 2, and I get y equals 8. So my ordered pair then would be negative 3 comma 8. And if you remember back to what Malik said before, that put me right at negative 3 comma 8. So we can evaluate Sapana's strategy does in fact work, and that is why. So now we're going to choose our own strategy and use it to find the midpoint of the segments with negative 3 comma 4 and 2, 9. You are welcome to use either of the strategies, Sapana's or Malik's, to go ahead and find that. So go ahead and try it out on your own. Okay, hopefully that has yielded you some good results. Since I don't have a graph here functioning for me, and it's hard for me to picture things without being able to draw them myself, I'm actually going to use the algebraic method of Sapana a little bit more. So I will do that same thing where I will have, I'm just going to pick, let's see, I've got this one is my more negative on the x-axis, and this one's my more positive on the x-axis. So I will go x minus -3 equals 2 minus x. Okay, so I just use the x values here and here, and I will do the same thing with y values. I will go y minus 4 equals 9 minus y. I'll go ahead and now solve these. I'll do it a little bit more quickly. So plus x. These are positive, so I'm going to subtract 3. I get 2x equals -1, which means x equals -1/2. Interesting. And then I will do the same solution process over here. Add y to both sides. I'm going to add 4 to both sides as well. So I will get 2y equals 13. And then to simplify that, the final step is y equals 13/2. And hopefully you got those same values. So our ordered pair is -1/2, comma 13/2. And that is, in fact, the midpoint. So you can see that this process right here of algebraically solving actually will work pretty simply for us in any way. So now we're going to also use the same strategy to find the midpoint of the segment between x1 and y1 and x2 and y2. So go ahead and see if you can figure out one of those strategies to find the midpoints.